Welcome back to Cloud OnAir, the journey from big data to AI. I'm James Malone. I'm a product manager in Google Cloud. There's Googlers that are waiting to answer your questions in the Q&A, so if you have questions, please fire away. Today I want to talk about Google Cloud Dataproc. Specifically, I want to talk about how you can fast-track your Apache Spark and Hadoop deployments with Google Cloud Platform. So first, let's talk about typical Spark and Hadoop deployments and the reason why we have Cloud Dataproc in the first place. Typically, when you deploy Spark and Hadoop, it's not necessarily the most straightforward process. In fact, it's usually a really complicated path of things that most people don't enjoy. Moreover, it's a set of things that you have to do that don't really add value to the core effort of what you're trying to do, which is get actionable information out of your data in the first place. So common Spark and Hadoop deployments follow this pattern most typically. You have to obtain the servers, you have to configure some set of capacity. Once you have the capacity, whether it is on-premise or in a cloud, you then have to install the open source packages to actually use Spark and Hadoop. This may be a commercial Hadoop distribution. This may be a hand-built Hadoop distribution or just building things from source. Once you do that, you then have to configure, tune, and optimize them. Only once you're done with that, then you finally debug the setup and actually do what you wanted to do in the first place, which is get actionable intelligence out of your data. If you start this on a Monday, it's most likely going to take you hours, days, weeks, or months to actually set up your cluster. That is a totally broken setup, and we don't want that to happen. Moreover, if you want to add new capacity, you have to often go through this whole process again, which, again, does not add value to what you're trying to do, which is make use of your data. Ultimately, this causes a whole set of pains for you. First, scaling pain. So as I mentioned, when you want to grow or shrink the size of this cluster, you often have to add capacity, take time, spend resources to grow and shrink your Hadoop cluster. Second, utilization pain. It's really hard to hit a constant use of this cluster over time. That ultimately means that your use is going to be spiky. Sometimes you're going to be saturating the cluster with a whole bunch of work. Sometimes you're going to have a cluster that is not doing a lot, and you're basically just paying to run it at that point in time. This ultimately means that you're paying for probably more than you use. Most people typically over-provision their Spark and Hadoop clusters. So often they'll pay for more capacity than they need because they actually just want the ability to process data when they need. Ultimately, that just is kind of wasting your money, and we don't want you to do that. Ultimately, with Cloud Dataproc and our managed Spark and Hadoop solution in Google Cloud Platform, we're trying to solve all three of these pains at once. So let's talk about what Cloud Dataproc actually is. So Cloud Dataproc is designed as a fast, easy, and cost-effective way to run Spark and Hadoop in Google Cloud Platform. We leverage both the software and hardware aspects of Google Cloud Platform to provide you a Spark and Hadoop solution that is fast, easy, and cost-effective. So let's define these terms, because it's really easy to talk about fast, easy, and cost-effective. And I want to be specific about what we're trying to solve in designing this Spark and Hadoop solution. First, fast. Things should really take on the order of seconds. They shouldn't take minutes, hours, days, or weeks. So for example, when you create a cluster or resize a cluster, that should take on the order of seconds, 60 to 90 seconds. Easy. We want people that are using this to be experts in what matters, which is typically the data. We don't want people to have to be experts with the Spark and Hadoop tools that they're using. And cost effective. We want people to pay for exactly what they're using. If you use 37 minutes of a cluster, we want you to pay for 37 minutes of a cluster. Ultimately, Cloud Dataproc is kind of an endpoint in the journey from do-it-yourself to a cloud migration. So typically when you run Spark and Hadoop on premises, you're responsible for almost everything. You have to create the cluster, you have to manage your code, you have to babysit resources, hardware, capacity, utilization, all of that. When you take the next step and just move that cluster from on-premises to a cloud, you give up a whole lot of work. So you no longer have to think about running the actual hardware. Often you don't have to think about deployment of VMs. All of that is taken care for you by a cloud platform. With Cloud Dataproc, we want to take away everything except you actually getting valuable use out of your data. So we want to take over things that don't add to that, like monitoring your cluster, deployment, reconfiguration, resizing. We ultimately want to enable people to get value out of their data. So Cloud Dataproc is really the end of this pathway from how people typically run Spark and Hadoop to moving to a cloud. So we also don't want the cluster to just be by itself. Often, Spark and Hadoop clusters have a nasty habit of being sort of a thing that people move data to and use separately from their infrastructure. With Cloud Dataproc, we want to be able to provide you Spark and Hadoop clusters that you can use with other products in Google Cloud Platform. So for instance, we want to bring Spark and Hadoop to things like Dataflow or Cloud Pub Sub or BigQuery. We don't want your cluster to feel like a separate experience. Instead, we want to bring Spark and Hadoop to the larger platform itself. This ultimately means that not only do we develop Cloud Dataproc as a solution to run Spark and Hadoop, we also develop connectors so you can actually use Cloud Dataproc with other Google Cloud Platform products. For instance, you can use things like BigQuery to store and query your data and also use them in conjunction with Cloud Dataproc. We don't want your cluster to be an isolated, separate thing from the rest of your data processing stack. We want to be able to bring it to the rest of the power of Cloud Platform. We've also tried to make it really easy to lift and shift or to actually onboard to Dataproc. So typically you'll have to do three things when you start using Cloud Dataproc, and it's really by design. First, you'll have to copy at least some subset of data to Google Cloud Platform. Typically, when most customers start using Cloud Dataproc, they move just a subset of their data just to test things out and see how things work. Once you move a subset of data, you have to update your code. But thankfully, typically most people have to do is just update the URI prefix of their code. Instead of pointing to something like HDFS, you just point to Google Cloud Storage. So you change the URI prefix from HDFS to GS to point from HDFS to Google Cloud Storage. Typically, that's all people really need to do when they start using Dataproc. Once you make that small change, you're ready to go. So often onboarding to Cloud Dataproc involves just copying your data, making one very small change, and then getting started. We've also really tried to focus on cost. So going back to the idea that really drives every feature that we develop for Cloud Dataproc, that it should be fast, easy, and cost-effective. Cost effectiveness is often a really big pain point with Spark and Hadoop clusters. And with Cloud Dataproc, we've really tried to solve this problem head on. If you look at the savings between running on-premises or even other clouds in Cloud Dataproc, you can save a considerable amount of money. And this is due to a few reasons. First, you only need clusters when you actually have data to process. Second, we've tried to price Cloud Dataproc so it is cost-effective whenever you are using it. And we've also can take advantage of Google Cloud Platform to do things like separating storage and compute, which I'll actually talk about in just a few minutes here. Ultimately, the point here is the Apache Spark and Hadoop ecosystem is really powerful, but a lot of people often run into cost-effectiveness concerns when they create these clusters. So let's take a look at the internals of Cloud Dataproc. So we're going from an orbital view of why we created the service to a very specific view of how the service runs. So under the hood, Cloud Dataproc takes advantage of a whole bunch of foundational Google Cloud Platform technologies. When you create a cluster, we use things like Google Compute Engine, Cloud Storage, and Persistent Disk. This means that you get the benefits of multiple Cloud Platform products, all tied together when you create your Spark and Hadoop clusters. So when you create a Cloud Dataproc cluster, we provision a cluster on Google Compute Engine. You have the ability to use both persistent virtual machines and also preemptible virtual machines all in one cluster. When you create a cluster, we also typically advise people to use cloud storage, which I will talk about in just a few minutes here, instead of using things like persistent disk and HDFS. The reason for that is you can often save a lot of money and speed up your workloads. Cloud Dataproc also supports its own identity access management, or IAM layer, and you can use things like Cloud Path and other networking options with your Cloud Dataproc clusters because we're built on the foundational Google Cloud Platform technologies. Specifically, when you create these nodes, we create a Cloud Dataproc image that's based on Apache BigTop. So we essentially download all of the open source, apply fixes, patches, optimizations, build a Hadoop distribution that's based directly on open source, and then layer it on top of Cloud Dataproc clusters. Those clusters have their own control plane and control machinery that allows us to do things like provision clusters, resize them, submit work to them. Cloud Dataproc also has its own set of web APIs. So you have APIs for things like creating and managing clusters, creating and managing jobs, creating and managing operations. Ultimately, all of our tools that you would use for Cloud Dataproc are built on top of these APIs. That means that you have a great set of tools that you can use if you don't want to do custom programming against Cloud Dataproc, but it also means that you have a really powerful and rich set of APIs that you can use if you do want to script and program against Cloud Dataproc. When you create clusters, you can also install and maintain your own software on clusters. So typically what this looks like for customers is they'll do things like install Jupyter or Zeppelin or Presto, which I'll actually show in a demo in just a few minutes. This really allows you to expand and customize and configure your cluster however you would like. So I want to talk about some of the core concepts of Cloud Dataproc and how these help you fast track your deployments when you choose to use Cloud Dataproc as part of your overall data and analytics stack inside of Google Cloud Platform. So one of the big concepts here with moving to a cloud-based Spark and Hadoop solution is the disambiguation or the disaggregation of storage and compute. So instead of having your cluster both perform data processing tasks and storage, you instead get to separate your cluster out. So you have storage in one mechanism, and then you create your cluster to do your processing and analytics. This means that your data is persistent outside of your cluster. So when you create or delete your cluster, you don't have to worry about the persistence of your data. It also allows you to have multiple clusters that can act on your data all at once. So for example, you could have all of your data in one cloud storage bucket and use multiple clusters to process it all at once. It also means that you can often access cost optimizations and savings. So for instance, if you have data that is partitioned by date, you can partition your data inside of cloud storage and use some of the different tiers of cloud storage to save on data that you access less frequently. This is really an optimization that both allows you to save on the cluster itself because you don't need to size your cluster just to store data. It also allows you to potentially optimize on the spend for just storing your data in the long term. Ephemeral and long-lived clusters. So typically when people run Spark and Hadoop clusters, they're running one very long-lived cluster all the time. It is a very persistent, long-lived cluster. With Cloud Dataproc, you can run a long-lived, persistent cluster if you want, but you can also run clusters that are just scoped to the work that you have to perform. So for example, if you have a bunch of Java MapReduce or PySpark jobs that run at a specific point in time at a given day, you can create a cluster, run those jobs, and then delete the resource once you're done. If you need a long-lived cluster, you can definitely keep a long-running cluster on for as long as you would like. And you can scale that cluster over time. So if you have a long-running cluster and you need to add or remove resources, it's very easy to do. But if you don't need a long-running persistent cluster, you can create these very small scoped clusters that are ephemeral to the work you have to perform. And that means that you spend less because you're only using resources when you actually need them. But it also means that you can create clusters that are scoped in size for specific workloads. In addition, with Cloud Dataproc, you can do things like access different versions of Cloud Dataproc. So if you wanted to test out the newest version of Apache Spark with your clusters, you could create a cluster with our preview image, which typically has new builds of Apache Spark, test out your code, see how that new version works, and then delete the cluster when you're done. You don't need to worry about creating complicated development environments. You don't need to worry about monkeying or tinkering with your existing clusters of work. Instead, you can create these clusters that are scoped very specifically for things that you want to do when you actually need them. I mentioned that you can create clusters that are scoped to specific use cases. So for example, a job that uses Hive may act and have a lot of different properties than a job that is maybe based on PySpark, or maybe you're using Spark ML and you want to use GPUs. Well, if you're using something like GPUs with Spark, you probably don't need those GPUs when you run your Hive work. So with Cloud Dataproc, you can create clusters that are specifically sized and scoped for the work that you have to do. So you can have a cluster that is specifically created just to run your Hive workloads. You could have a cluster that is specific to just running ML workloads. This ultimately ensures that you have really good controls on how much you spend, how quickly things get done, and how your cluster looks and functions over time. There's also a whole set of specific features in Cloud Dataproc that I want to talk about that if you're curious about trying out a cloud-based Spark and Hadoop solution may save you time and money. Let's talk about resizing clusters. Typically, this can be a really complicated effort when you're running a large persistent cluster on premises. With Cloud Dataproc, you have several options for scaling your clusters over time. First, you can just scale your clusters outright. So you can add and remove workers from your cluster whenever you want. Typically, this operation is about as fast as creating a cluster, so it usually is done in about 60 to 90 seconds. Second of all, you can use core Google Cloud Compute Engine concepts like custom VMs. This allows you to create a cluster that is very specific to the workloads you want to run. So for example, if you have a workload that you know maybe requires 6 CPUs, but a whole bunch of RAM, you can create a custom VM and use that custom VM with your clusters and have a cluster that is very specifically scoped to the work you have to perform. Third, preemptible virtual machines. So preemptible virtual machines are a Google Cloud Platform concept. Typically, the trade-off is you will lose a virtual or a preemptible VM within 90 seconds, but you save a whole lot on compute workloads. With Cloud Dataproc, we've designed the service to work with preemptible VMs, and they're really great for compute-intensive workloads because you can create these clusters, use preemptible VMs, and the service is smart enough to add and remove preemptible VMs as they're available or taken away. Cluster customization. So often people want to add additional things to their cluster or change how the cluster works. This might be modifying your yarn site file or adding specific properties to your cluster. There's two ways to do this with Cloud Dataproc. First, you can run what we call initialization actions. These are scripts which run as root when you start the cluster, and they essentially allow you to customize the cluster in almost any way you want. The second option is to use our Cluster Properties API or the tooling around it. These allow you to modify a set of known Spark and Hadoop configuration files. You specify which file you want to change and then a property key value pair. The service itself will go touch these property files so you don't have to. It's less risk and much easier than trying to do things like SSH into every node to change configuration settings or just do it by some other means. We also have a concept of cluster deletion. So one very common concern when people are exposed to cloud-based Spark and Hadoop is it's really easy to create and destroy clusters. People often have a concern that somebody might create a cluster and forget about it and let it run forever and ever and ever. So with scheduled deletion, when you create a cluster, you can specify a maximum lifetime, an idle period, or a specific date, or multiple of the above. When you do this, the cluster is automatically deleted at that point you specify, so you don't need to worry about the cluster just persisting forever and ever and ever. Another feature that we just recently released is workflows. So often people want to create a cluster and run one or more jobs and then have that cluster go away. In the past, you had to do all of that separately. So you had to create a cluster, submit your work to it, monitor the progress of that work, and then once the work is done, you would ask the cluster to delete itself. With workflows, we've made that much, much easier. So you can instead submit one workflow request. In that request, you specify what the cluster should look like in terms of size, scope, location. You also submit the work that you want to run on that cluster, and then you just submit the workflow itself. Once that workflow is done, the cluster is automatically deleted. This makes it really easy to lift and shift work to Cloud Dataproc because instead of all of these complicated operations to create clusters and run work, you just need one operation. You just submit a workflow. That workflow creates the cluster, runs the work, and deletes that cluster. It's a tool that we've devised to try and both help people move to an ephemeral world where they only have clusters when they need them, but also make it really easy to use Cloud Dataproc so you don't have to think about all of these various steps in creating clusters and monitoring job progress. We also have a feature that allows you to specify per cluster identity access management credentials. So a very common concern, especially for enterprise customers, is how do I secure my data? And that's a very important concern. So with Cloud Dataproc, you can create clusters and scope them with very specific user credentials. You can specify users or groups that can do things on that cluster and specifically tied to that cluster. I want to quickly talk about some of the best practices with Cloud Dataproc. First, if you start using Cloud Dataproc, we really try to help people split their clusters and jobs. So if you have jobs that you want done very quickly, you can create a very large cluster scope to run your clusters very quickly. If you have long-running jobs and you don't want to spend a lot, you can create clusters that are specifically sized and scoped for just that. Splitting your clusters and jobs will ultimately allow you to potentially realize cost savings over time and also ensure that your clusters meet whatever SLAs or other requirements you have. So if I wanted to create a development cluster just to test out new versions of Spark and Hadoop, I can do that, and when I'm done with my tests, I can just delete my cluster. I don't need to worry about copying data, moving things around. Instead, I can use the mechanisms of Cloud Dataproc to create clusters that are specifically scoped for the tasks that I want to perform. You should also create and delete your clusters often. If you have work to do, you can create a cluster, run your jobs, and delete your cluster. There's really no reason to run your cluster persistently. Especially since you can generally get clusters in under 90 seconds, you really only need to create clusters when you actually have work that you want to perform, and you don't need to leave them running when you don't have work to perform. You should also use cloud storage. So as I mentioned, cloud storage is a replacement in Cloud Dataproc for HDFS. When you create a cluster, we run HDFS, but it's typically only for temporary operations. So shuffling, spilling, things like that. Aside from that, cloud storage offers you typically better speed and economics versus running HDFS on a cluster. Plus, it also means that when you create and delete clusters, your data is not specifically tied to that cluster. Ideally, if you're scripting against Cloud Dataproc or just submitting work to it, the Jobs API will make life easier for you. So instead of using things like SSH or things like Hue, you can instead either use our client tooling or our Jobs API to submit and run work on your cluster. I'll show this in the demo in just a minute. You can also use tags with your cluster. So tags are key value pairs that you can use and associate to your cluster. These allow you to do things like cost accounting. You can get and list clusters by the tags. So maybe I have a fleet of production clusters. If I wanted to add more capacity to my production cluster setup, I simply only need to create a cluster and add a tag that identifies it as a production cluster. If I wanted to remove that cluster for deletion or maintenance or whatnot, you can just remove that tag. Alternatively, if you wanted to see how much your accounting group, for instance, uses your Spark and Hadoop cluster, you can submit jobs with that tag to get very specific accounting tied to that group. In terms of data migration, you really should use cloud storage instead of persistent disk. It will give you much better economics, it will give you much better speed, and it also makes sure that your cluster is not specifically tied to your data locality. So if you delete your cluster, we obviously don't want you to lose any data. You should really think about how you segment your data when you move to cloud storage, because you could potentially use the various tiers of cloud storage to save time and money. In terms of cloud storage versus persistent disk, cloud storage will usually give you better throughput. In some rare cases, things like append don't really work all that well, or if you have very small files, you may notice that latency is going to be higher than HDFS. These are not common use cases, but it's a good thing to keep track of and think about when you plan your data migration to cloud storage. So I want to quickly show you how easy it is to create and delete clusters with Cloud Dataproc. You can see that I filled out a few default options here just to save time. In the web UI, there's the option to both create clusters and jobs, and this is the cluster creation form. I specified a few default options. In this case, I've done things like specify a name, a zone, and the configuration of my cluster. We're going to create a modestly sized cluster here. It has 100 workers with 16 cores. We'll have 1,600 total yarn cores. I'm also going to run an initialization action to install Presto on my cluster. You can also see at the very bottom, if I wanted to do this via REST, there's a very easy way to do that with our REST API. There's also a really easy way to do it via our command line. So if I wanted to use the Google Cloud SDK to create this cluster, it's very easy to do. In this case, I'm just going to go ahead and use the web UI to keep things simple. So once I create the cluster or click the Create button, the cluster is going to provision itself behind the scenes. I'll come back to this cluster in just a moment. I've also filled out a form to submit a job to the cluster. So in this case, I've specified the cluster where I want to run this work, which is the cluster I just created. We support a number of job types. These are workloads that you can run on a cluster. So you can see that we support things like Hadoop or Spark or PySpark. In this case, I'm running pig because I'm actually using pig to shell out and then go call Presto. It's a somewhat convoluted use case, but I do want to show that you can really use a cluster any way you want. Just because you're using things through Cloud Dataproc, we try not to restrict you or box you in. You can see the SQL file that I'm running against this cluster, and I've also added an optional label to this cluster. So in this case, I'm adding a label where group is equal to demo. So later on, if I wanted to see all of the jobs where the group was equal to demo, I could easily do that. Again, it allows me to do things like cost accounting or resource usage. If we quickly go back to our cluster and open up the cluster details, you can see that Cloud Dataproc provides you a really high-level overview of the cluster. So in this case, we can do things like look at CPU utilization, we can look at network I/O. This allows you to just get a orbital level view of what is running on the cluster or how your cluster is functioning. In addition to this view, you can also use things like Stackdriver to get detailed log and resource usage of your cluster. Behind the scenes, if you're paying attention, you can also see that this turning wheel turned to a check mark. So the cluster is ready to use. So in just the time that I've been talking, the 1600 core cluster is ready to go. You can see what work has been submitted to the cluster, which is nothing right now. You can also look at the virtual machines that are attached to this cluster. So you can see that there's a whole lot of compute engine instances that are part of this cluster. And you can do things like resize this cluster. So just to show you how flexible Cloud Dataproc is, let's go ahead and resize this cluster before I submit some work. The reason for showing you that is to really underscore the fact that if I modify this cluster, I don't have to stop submitting work to this cluster. I don't have to worry about my cluster being unavailable. Cloud Dataproc is designed to handle all of these things behind the scenes. So my cluster is in the process of resizing itself. Let's go ahead and submit that work to the cluster. Once I click this submit button, you can see that the job is going to start processing on the cluster. In addition, if we go back to that cluster view, we'll be able to see that that job is now associated with this cluster. Moreover, we do things like capture output from the cluster. So I don't need to do things like open up SSH terminals or worry about losing logging output. The Cloud Dataproc Jobs API is really designed to make it as easy to use without giving you less information or abstracting things away too much. Once this cluster is done processing this job, we can also just simply delete this cluster. So in this case, let's go ahead and just say that we were done with the cluster. When I'm done with it, I can just simply click this delete button and the cluster would go away. So again, when I have work to do, I can create a cluster and run the work, and then when I'm done, I just click the delete button and don't have to worry about the cluster sticking around. So there's a few key takeaways that I want to talk about in terms of Cloud Dataproc. First, we've really tried to make Cloud Dataproc as fast as possible. Again, you could see that we were able to create a modestly sized cluster pretty quickly. We were able to submit work to that cluster pretty quickly. We want you to be able to move as quickly as possible with Spark and Hadoop without worrying about the infrastructure or management of clusters. Second, we want Cloud Dataproc to be easy. Again, you saw me submit a bunch of SQL to the cluster without having to open a terminal window or log into additional applications. If you have work to do, we want you to be able to submit work to the cluster as easily as possible. And third, cost effectiveness. So when I create that cluster, I'm billed with a 1-minute minimum increment, and I'm billed by the second thereafter. So if I use, for example, 800 seconds of a Cloud Dataproc cluster, I will be billed for 800 seconds of a Cloud Dataproc cluster. We don't want you to have to pay for more resources than you need just to use Spark and Hadoop. I'm James Malone. Thank you very much for joining this session, and please stay tuned for other Cloud OnAir sessions.